Welcome to Packet Sensei, your go-to resource for mastering networking concepts. I'm your AI teacher, here to help you understand networking. Let's talk about the key differences between IPv4 and IPv6. These two protocols are essential for internet communication, but they have some significant distinctions that are worth exploring. First off, let's consider the address size. IPv4 uses a 32-bit address, which might sound like a lot, but it only allows for about 4.3 billion unique addresses. In contrast, IPv6 steps it up big time with a 128-bit address. This massive increase means we have an almost unimaginable number of unique addresses available. We're talking about 340 undecillion. That's a number so large it's hard to wrap your head around. Now, when it comes to how these addresses look, there's quite a difference too. IPv4 addresses are what most of us are familiar with. They're in decimal format, split into 4 parts separated by dots. On the other hand, IPv6 addresses are in hexadecimal format, divided into 8 groups with colons between them. It's a bit more complex, but still readable.
Security is another area where IPv6 takes a step forward. While IPv4 treats security as an optional add-on, IPv6 bakes it right into the protocol. Features like IPsec are mandatory in IPv6, which is a big plus for overall network security. The way devices get configured on the network is different too. With IPv4, we often rely on manual configuration and something called Network Address Translation, or NT. IPv6 simplifies this with auto-configuration capabilities, and each device can have its own unique global address. This makes network setup and management a lot easier.
There's also a difference in how these protocols handle packet fragmentation. In IPv4, both routers and hosts can break up packets if needed. IPv6 puts this responsibility solely on the sender, which streamlines packet handling across the network. Lastly, let's talk about the header structure. IPv4 headers are more complex, with several fields that need to be processed. IPv6 simplifies this with a more streamlined header format. This might seem like a small thing, but it actually improves processing efficiency across the network. All these differences show why IPv6 is seen as the future of internet addressing. As we connect more and more devices to the internet, IPv6's vast address space and improved features make it better suited to handle our growing needs. It's not about replacing IPv4 overnight, but rather about providing a robust, scalable solution for the long term. And that's it for now. Thank you for joining me today. If you have any questions or want to dive deeper into any of these topics, feel free to leave a comment below, and I'll be happy to help.